Imagine you open a PLC program and you see hundreds of lines of structured text. Some lines are performing calculations. Some are controlling motors. Some are making logical decisions. But behind every single one of those lines, there is one simple building block: a variable. In the previous video, we started our journey into structured text programming. We talked about how PLC programming languages evolved, from ladder logic to function block diagram, and finally to structured text, the language that allows PLC programmers to think like software engineers. We also discussed why structured text is becoming extremely important in modern automation, especially when machines become complex, calculations become heavy, and logic becomes more intelligent. And we ended the video with one very important statement. In structured text, nothing exists unless you declare it. Every input, every output, every calculation, every flag, everything begins with a variable. And that is exactly what we are going to understand today. Welcome back to Mr. Smart. Let's start learning. In this video, we are going to dive deep into one of the most important foundations of structured text programming: variables and data types. And trust me, if you truly understand this topic, writing PLC programs will become much easier, cleaner, and safer. Because many real industrial problems actually start from something very small: using the wrong data type. So let's start from the very beginning. What exactly is a variable? A variable is simply a named memory location inside the PLC. Think of the PLC memory like a huge storage cabinet with millions of tiny drawers. Each drawer can store some information, but instead of calling them with drawer number, we give them names. For example, motor start, temperature, pressure value, conveyor running, alarm active. These names represent memory locations where the PLC stores values. During every PLC scan cycle, the program reads these values, processes them, and writes new values. So variables are basically containers that hold information. Now here comes the important part. Not all containers are the same. Some containers store true or false values. Some store numbers. Some store decimal values. Some store text. Some store time information. And some store complex data structures. This is where data types come into the picture. A data type defines what kind of value a variable can store. Before we go deeper into data types, we need to understand something very fundamental in digital systems. And that is the concept of bits. Inside a PLC, everything is stored in the form of binary data. That means the PLC only understands two states: 0 and 1. These two states are stored using something called a bit. A bit is the smallest unit of memory in any digital system. One bit can store only two possible values: 0 or 1, false or true, off or on. Now when we combine multiple bits together, we can store more information. For example, if we combine two bits, we can represent four values: 00, 01, 10, and 11. Similarly, 4 bits can represent 16 possible values. And when we combine 8 bits, we create something called a byte. An 8-bit value can represent 256 different numbers. That is why many PLC data types are based on 8-bit, 16-bit, 32-bit, or 64-bit memory sizes. So when we talk about data types, we are basically deciding how many bits of memory should this variable use. And this directly affects the range of values the variable can store. You can think of data types like different types of boxes. A small box cannot hold a large object. A numeric box cannot hold text. And a Boolean box can only hold two possibilities: true or false. In PLC programming, using the correct data type is extremely important because it directly affects memory usage, calculation accuracy, program performance, and sometimes even machine safety. So now let's go through the most important data types used in structured text. The first and simplest data type is BOOL. BOOL stands for Boolean. A Boolean variable can only have two values: true or false. In electrical terms, you can imagine this like a digital signal, on or off, 1 or 0. For examples, the BOOL variables could be start button, emergency stop, motor running, door closed, and alarm active. Whenever you are working with digital inputs, digital outputs, or logical conditions, BOOL is usually the correct data type. For example, take a look at working of this logic. Here, every variable involved is a Boolean value. Simple, clean, and very fast for the PLC to process. Next, we move to integer numbers. Integer numbers are whole numbers without decimals. And in PLC programming, there are several types of integers depending on their size. Now here is another important concept related to integer data types. And that is the difference between signed and unsigned numbers. A signed number can store both positive and negative values. Integer, double integer, and short integer. These are signed data types. They reserve 1 bit to represent the sign of the number, which means the value can be either positive or negative. For example, -10, -9, 0, 9, 10. But sometimes we know that a value will never be negative. For example, number of products produced, tank level percentage, and machine cycle count. These values will always be 0 or positive. So instead of wasting memory to represent negative numbers, PLCs provide unsigned data types such as unsigned integer, unsigned double integer, and unsigned short integer. These data types don't store negative values. They can use their entire bit range for positive numbers, which means they can store larger positive values compared to signed types using the same memory size. This becomes very useful in industrial communication and large counters. Let's start with INT. INT stands for integer, typically a 16-bit signed number. That means it can store values from approximately -32,768 to +32,767. You might use integer variables for things like speed set points, counter values, temperature readings, and production quantities. For example, parts produced. Now, sometimes 16 bits are not enough. Imagine a machine that counts products for several days. The number might become very large. This is where DINT comes in. DINT stands for double integer. It is a 32-bit signed number, meaning it can store extremely large values. Typical range is around -2 billion to +2 billion. So if you are storing large counters, machine runtime values, or big calculations, DINT is often the safer choice. There is also SINT, which is a short integer. It uses only 8 bits, so its range is much smaller. This is used when memory optimization is important or when working with communication data where byte-sized numbers are required. Now let's talk about unsigned integers. Sometimes we know a value will never be negative. For example, product count, tank level percentage, recipe number. In these cases, we can use UINT. UINT means unsigned integer, which only stores positive numbers. Because it doesn't need to store negative values, it can use its memory more efficiently. Similarly, we also have USINT, unsigned short integer, and UDINT, unsigned double integer. These are very commonly used in industrial communication protocols and data exchange. Now let's move to one of the most important data types in automation: real numbers. Real numbers store decimal values. Whenever you deal with physical measurements like temperature, pressure, flow rate, speed, and distance, you will almost always use real. Real numbers use floating point representation, which allows decimal calculations. But they also require more processing power compared to integers. That's why in very high-speed PLC tasks, engineers sometimes prefer integers when decimals are not necessary. There is also LREAL, which stands for long real. This is a 64-bit floating point number, providing extremely high precision. LREAL is often used in advanced motion control, scientific calculations, and energy monitoring systems. Another interesting data type is string. String allows the PLC to store text. This is used in applications like HMI messages, alarm descriptions, recipe names, and operator inputs. Strings are very useful for communication between PLC and HMI systems. However, they consume more memory than numeric variables, so they should be used wisely. Now let's talk about something extremely useful when programs start becoming larger, and that is arrays. An array is basically a collection of variables of the same data type stored together. Instead of creating many individual variables like box ID 1, box ID 2, and box ID 3, we can group them into a single array. All of these belong to the array which of type string. This is very useful when dealing with things like multiple sensors, production data, batch values, recipe parameters, and data logging. For example, imagine a machine with 20 temperature sensors. Instead of declaring 20 separate variables, we can simply create an array of size 20, named temperature sensor of data type real. Now the PLC automatically creates 20 real variables inside that array, and we can access them using their index number. Arrays make PLC programs much cleaner, scalable, and easier to manage. And later in this series, we will also see how arrays work together with loops to process large amounts of data very efficiently. Now, as PLC programs grow larger, engineers often group related variables together. This is where the special or user-defined data types such as structure or struct, time data types such as TON, TOF, TP, functions, and function blocks come in. This keeps programs extremely organized and easier to maintain. And in large automation systems, this kind of data types in programming becomes very powerful. We will look about all these things very detailed in our upcoming videos. Now here is something very important that many beginners overlook. Declaring variables properly is not just about syntax. It is about writing programs that humans can understand. Imagine opening a program where variables are named like x1, A23, temp2, and flag7. After 1 month, even the original programmer might not remember what these mean. But if variables are named clearly like conveyor running, tank level %, and emergency stop active. The program becomes self-explanatory. Good automation engineers don't just write programs for machines. They write programs for future engineers who will troubleshoot those machines. And that is why variable naming is one of the most underrated skills in PLC programming. So in this video we learned the foundation of structured text programming. We understood what variables are, how PLC memory stores them, and the most important data types used in industrial programs. Now that we understand how data is stored inside a PLC, if you enjoyed learning something new today, make sure to subscribe to Mr. Smart and share this video with friends or colleagues who want to learn PLC programming in a clear and practical way. Because the more we share knowledge, the smarter our engineering community becomes. And I will see you in the next video.